This is 2022 WAEC question under dimension. So let us read the question. The effective potential energy E of a lunar satellite of mass m1 moving in an elliptical orbit around the moon of mass m2 is given by E equals k squared over 2m1 r squared minus gm1 m2 over r, where r is the distance of the satellite from the moon and g is the universal gravitational constant of dimensions m raised to power minus 1, l raised to power 3, t raised to power minus 2. Determine the dimensions of the angular momentum k of the satellite using dimensional analysis. I told us earlier before now that if we are to determine the dimension of a quantity using the dimensions of other known quantities, all we need to do is to, in the equation, pick two terms and equate them, because every term in an equation, if the equation is correct, are dimensionally equal. So it means that E from this our equation we can see is equal to k squared. So put it this way, we can say that dimensionally E is equal to k squared all over 2 m1 r squared, and it is also equal to g m1 m2 over r. That this term is equal to this term and it is equal to this term dimensionally. And remember, I told you that in dimension constant is not used. The constant is insignificant in dimension, determining dimension. So what are we going to do? We can use any two. Since it is k, we are determining, we want to find its dimension. We can use this and this, or this and this. But since we were given the dimension of g and we can easily get the dimension of this, it will be easier for us to use these two instead of getting the dimension of energy, which will take us a longer time. So let us just use these two to get the dimension of k. Again, I told us that the quantities mentioned, or all the statements made in the question is not necessarily important. What is important for us is to know what every quantity in that statement represents and the relationship between the quantities in order to determine the dimension. We don't need to make meaning of the statements made. So our job is to be able to identify what each quantity represents. So let us take it this way. You can see, I can say, like I said, I can bring out this k squared all over m1 r squared. Forget about the two constant, it has no significance in dimension, equal to g m1 m2 over r. So we need to know what every quantity represents. We are looking for k, so we do not know the dimension of k. We write it k squared all over m1 here is mass and the dimension of mass is m. R here is the distance from what the question said. It says that r is the distance of a satellite from the moon. So r is distance and the dimension of distance is l. So we say l squared here equal to g. This g is said in the question to be universal gravitational constant and the dimension was given. So even if you don't know what universal gravitational constant stands for, you will know the dimension as given in the question. So g is from the question m raised to power minus 1, l raised to power 3, and t raised to power minus 2. Then we multiply it by dimension of m1 is m because it's mass. Dimension of m1 is m. Dimension of m2 is also m because it's also mass, divided by r, and the r is the distance. So the dimension of r is l as well. So knowing this, we can put it together, collect like terms. Here we have k squared. This is now simplification we are doing. We have k squared all over m l squared is equal to m raised to power minus 1. If you put these two m's together, m times m will give you m raised to power 2, l raised to power 3, and t raised to power minus 2 all over l. Okay, then we can cross multiply to have k squared l. If you cross multiply, this will multiply this and this will multiply this. So we have k squared l is equal to m l squared m minus 1 m 2 l raised power 3 and t raised power minus 2. We have cross multiplied. We collect like terms from this side. You see this m, because there is no power written on it, the power is 1. Of course, we know from the law of indices. So this is m raised to power 1. This one is minus 1. This one is 2. So you put them together to have m raised to power 1 minus 1 plus 2 from the law of indices. And then l and l will be put together to be l raised to power 2 plus 3. While t, we have only one t here, t raised to power minus 2. So if we simplify further, k squared l is equal to 1 minus 1 is 0 plus 2 is 2. So we have m raised to power 2 here. 2 plus 2 will give us 5. So you have l raised to power 5 here. And then t raised to power minus 2. So you have t raised to power minus 2 here. So from here, to make k the subject of formula, we have to divide both sides by l. So we have k squared l all over l is equal to m squared l raised to power 5 t raised to power minus 2 all over l. So when that is done, this l will cancel this l, and we have k squared is equal to m squared l. Here we cancel one l. L here we cancel one l here, so we are left with l raised to power 4 and then t raised to power minus 2. So having it like this, remember it is k we are looking for, not k squared. So from the law of indices, we find the square root of both sides in order to eliminate this square. So the square root of k squared is equal to the square root of m squared l raised to power 4 t raised to power minus 2. The square root will cancel the square, so that k will be what? Square root of m squared is m, because the square root will cancel the square. Square root of l raised to power 4 is l raised to power 2, and square root of t raised to power minus 2 is t raised to power minus 1. So dimensionally, the dimension of k, which it was referred to as angular momentum in the question, is m l raised to power 2 t raised to power minus 1, as we can see. Another question from WAEC, they said the force F acting on the wings of an aircraft moving through air of velocity v and density is given by the equation F equals kv squared p squared p kv raised to power x p raised to power y a raised to power z, where k is a dimensionless constant and a is the surface area of the wings of the aircraft. Use dimensional analysis to determine the values of x, y, z. Just like we've said, every term in the equation is equal to another dimensionally. So F is equal to all quantities put together in the right hand side, because they are all one term. So if we compare that, all we need to do is to find the dimension of the right hand side and the dimension of the left hand side, and then know what the powers will be. We equate the powers. So let us see how that is done. We have F, is equal to k v raised to power x p raised to power y a raised to power z, and we know what all these quantities represent. F is force, and force, let us split it. Force is mass times acceleration. K is a dimensionless constant, so we can ignore it. V here is velocity, which is displacement over time. Velocity, which is displacement over time. So we use S to represent the displacement. Displacement over time raised to power x. Y P here stands for density. Y density is mass over volume. We use m over v to represent it, raised to power y. And then A is area. We can say area of anything. Area of a rectangle is length times breadth. We can use length times breadth to represent it, raised to power z. So if we split further, we have mass. Acceleration is velocity over time. We have it equal to, this is distance, because this from velocity we got displacement over time. So the dimension of displacement here is L, time is t, raised to power x. Dimension of mass here is m, and the dimension of volume is L raised to power 3. We can remember length times breadth times height raised to power y. Then the dimension of length times breadth is L squared raised to power z. So we have been able to split all this. So if that is the case, if you look at this, dimension of mass here is m, dimension of velocity here is the same as this velocity we have here, L over t, then divided by this t, we have L over t squared is the dimension of velocity over time. That is equal to, put this one together, we have Lt raised to power minus 1 or raised to power x. Put these two together, we have m L raised to power minus 3 or raised to power y. Then this one will be L raised to power 2 raised to power z. So if we simplify further, in the left hand side we have m Lt raised to power minus 2, remember, is equal to, then in our right hand side, if we open this bracket, we have L raised to power x, t raised to power minus x, because this is minus 1 times x. And then this second bracket with m raised to power y, then L raised to power minus 3y when the bracket is opened, while the third one is L raised to power 2z. So having done this, the left hand side remains m Lt raised to power minus 2, while the right hand side we collect like terms. We have only one m here, so we'll say m raised to power y. Then put the l's together, we have L raised to power x minus 3y plus 2z. From the law of indices, you add the powers. Then t, here we have c raised to power minus x. So having put these together to have just mlt, what we need to do is to compare the left and the right hand side of the equation. So m here and m here will be compared, L here and L here will be compared, then while t and t will be compared. And the power of m here is 1, so you write it 1 equals the power of m here is y, so you put it y is 1. The same here, the power of L here is 1, the power of L here is x minus 3y plus 2z. So you equate it. The third equation, the power of t here is minus 2. The power of t here in the second from the right hand side is minus x. So you equate it. This implies that our y is equal to 1. And in the third equation, our x is equal to 2 because minus will cancel minus. Then if y is 1 and x is 2, we equate y and x in this other equation so that we have 1 is equal to x is 2 minus 3y is 1, then plus 2z. Then we solve further. 1 is equal to 2 minus 3 times 1 is 3 plus 2z. Then 1 is equal to 2 minus 3 is minus 1 plus 2z. Then we collect like them. This one will cross to be 1 plus 1 is equal to 2z. That means that 2z is equal to 1 plus 1 is 2. Divide both sides by 2 so that z is equal to 1. That means that our x is 2, y is 1, and z is 1 from our dimension. So that is what we are asked to solve for in this particular question. So that is how that works. Thank you for listening and watching. See you next time.